Symposium. My name is Jack McCarthy. I'm with Integrated Design Group. We're the hosting organization for this event. This is our third symposium overall, our second in Dallas. Those of you that were here last year, we welcome you back. And those of you that are here new, we hope this is the first of many repeat appearances. So the audience and the presentation group represent our unique mix of data center end users, commercial real estate advisors, economic development representatives, and co-location professionals. The idea is to keep this program interactive throughout the day. Each presentation will end in a question and answer period. And at the end of the day, there's going to be an open forum hosted by Mark Monroe, where we expect to have some open information exchange among the presenters and the audience. Just give you a brief history of Integrated Design Group. We were established in 2003. We're an architecture and engineering firm with 100% focus on data center design. A couple of years ago, we broke out of New England and made our venture into the Dallas market, and I'm happy to say that we're growing pretty quickly down here, and we are now taking a foray into the Washington, D.C. market. The purpose of this symposium is to create a forum that provides unbiased expert advice, and the speakers represent notable leaders in the industry, offering an open exchange of current and forward-thinking ideas from a broad array of perspectives. I want to say a special thank you to the speakers that are coming here today to present to us, because we all know it takes a lot of time out of your day and the months of preparation for these types of events. It takes a lot of effort, and we appreciate the efforts of all, same as we appreciate your effort to attend today. I want to recognize the sponsors who made this event possible. The platinum sponsor is Schneider Electric. They'll be providing the cocktail reception that follows the event today. The gold sponsors are Data Centers Delivered, Miller Electric, and Structure Tone, and they're providing the meals and the refreshments during the breaks today. The silver sponsors include BTEC, C&D Technologies, Cummins, Cyrus One, Guidepost Solutions, Permalert, TD Industries, TechPlan, and Walker Engineering. They've also contributed generously to today's program. Without our sponsors, none of this would be possible. And I also wanted to make note that for the second year, the proceeds of the program are going to support a scholarship for the American Council of Engineering Companies. Moving on, I'll give you a brief overview of the agenda. You each should have a copy of this in front of you. There's two sessions today. There'll be a morning and an afternoon session, and we've got a break in the middle of each session. The focus in the morning is going to be modular data center design. In a moment, you're going to hear from Jason Schaefer from Tier 1. He's going to talk about the data center modular design revolution. After this, there'll be a 15-minute break with refreshments, and we encourage everyone to go out into the exhibit hall and visit the booths that our sponsors have set up. After the break, there'll be a case study of modular data center design, followed by an interactive panel session. There's a 1-hour lunch scheduled at 12:15. After that, we'll hear from eBay's Dean Nelson on the newly launched Project Mercury Data Center. Follow that will be my colleague Wayne Drooks of Integrated Design Group with a presentation on PUE. And we'll have another break in the middle of the afternoon at 2:30, where refreshments will again be served. And following that break, there'll be a panel discussion giving an overview of the Texas data center market. After that, Integrated Design Group's Chief Technology Advisor, Mark Monroe, will follow with a session of lessons we can learn from Internet superstars such as eBay. Mark will also moderate the open forum for a half an hour at the end of the day, which will be followed by the all-important cocktail hour. Each of you should have a name badge. You should be wearing it. In the back of it, there's a parking validation voucher. For those of you that need to conduct a little bit of business during the day, there's Wi-Fi access. Use SSID CPT. And if you're going to tweet about the data center, all good tweets, obviously, use hashtag 21CDCS. And if you could, during the presentations, please have your cell phones on vibrate or silent. I'm just going to briefly give a review overall of the design evolution that's occurred with respect to modular construction and design for data centers. Modular design is a relatively new concept in the data center market, but the concept of modularity has been around for quite some time. I've been doing this type of business since 1991. And when I first got into the business, I was doing industrial plants and power generating stations, and we had packaged equipment that was specialty assembled off-site and shipped on-site back in the day. It's everything from packaged generator systems to custom air handling units with walk-in enclosures and things of that nature. But only recently has it really taken a bigger step forward and creating major efficiencies with respect to schedule, quality control, and space savings. Our company, as a first foray into the concept of modularity, we were doing work in a developing country overseas, and one of the biggest issues we had was the lack of skilled labor in some of these areas. So we were working with major manufacturers to come up with a consolidated package that managed most connections prefabricated, pre-assembled, and pre-tested at a fabricating facility, and then it was shipped to site, whether it be on a freight car or whether it be on railway or whether it be on a barge, to be dropped in place and minimizing the connections on site. We had a whole lot of lessons we were learning in that process, and needless to say that things have streamlined quite a bit nowadays. And in virtually every data center project we're working on now, we've got some level of modularity in place. In fact, we're doing 3 in the Dallas area right now where we're using modular design. In the very beginning, I mean, these drawings here represent, and I'm not sure how clear they are, but they're just engineering drawings for a typical engine generator with a walk-in weatherproof sound attenuated enclosure. And these products have been made at least since the beginning of my career, and I think it goes back at least into the 80s, where if you think about the beginnings of modularity, you're talking about this is an engine generator, a fuel supply system, air intake and exhaust system, and sound attenuation, all built into one box. This box got shipped on a flatbed truck, got dropped into a site, typically landed onto a pad, and it was sitting outside in an equipment yard instead of taking up building space. Typically, this is tested as a system. It's fabricated at the location where it's fabricated. It's run through put through its motion, so the on-site assembly time and the testing time is minimized. Same thing can be said about switchgear. Switchgear has been available in packaged configurations for outdoor installation for quite some time. This is just an example of a typical switchgear in a walk-in enclosure. This is a generic picture, but we've gone through projects where we've had customers that just don't have room in their existing building. They need to augment or change out their electrical systems, and we'd wind up developing a design with a manufacturer, and they would wind up packaging it as if it's a little enclosure. It's basically it's a small house that would sit on a pad. The switchgear is on one side, and the access area is on the other side. So this gets dropped into a location. It's typically similarly on a pad. Underground distribution would extend into the existing building, and you'd remove the existing system, you'd replace it with the new system. And this product is not just for replacements, obviously. This is becoming more and more prevalent in modern day design, where we want to minimize footprint, the all expensive real estate that is inside the footprint of a building, where that could be revenue generating. You certainly don't want your infrastructure equipment taking up that space. So now this is a project that we actually did in New York, where we actually had combined generators and paralleling switchgear in a 3-module assembly. We had 3 modules shipped to the site. It's basically 2 packaged engine generator packages and 1 packaged switchgear enclosure, and we had them interconnected with quick connect devices wherever we could. We dropped these on site in off of 3 different flatbeds. Coupled them together. They were tested to the extent that they could individually off-site, and then we had them tested on-site as a full functioning assembly. And what it did is it minimized the on-site commissioning time, setup time, and overall testing was streamlined because we wrung out many of the issues at the factory when it comes to sequence of operation and what have you. So this has taken its way forward to UPS. Now this is an example of one manufacturer that happens to have a modular installation, where this isn't necessarily a walk-in enclosure, but it's certainly a modular enclosure that's packaged and pre-assembled and pre-configured. The access to this equipment is on the outside, So this could be dropped inside a building. This could also be dropped outside a building. It really depends on the owner and the end user and what their criteria is. But all of the equipment itself is, again, pre-wired, pre-assembled, and pre-tested, which just, it really streamlines the process. And you have to go through the process at the factory. You want to run through the tests. You want to run through the motions, because if you have it prepackaged there and you have it shipped to the site, you lose some of the efficiencies of having a pre-assembled piece of equipment in the first place. This shows a full assembly of the equipment coupled to an engine generator package, showing the real efficiencies of this is obviously you've got now a fully assembled UPS system, a fully assembled generator package, and you really had to connect the two together, and then you connect it to the building and you're up and running. Moving on to mechanical, this is a picture of a packaged pumping system. We're using this in quite a few of our projects, this typical approach, where we'd couple to a chiller plant that may be installed in more traditional stick-built installation with permanent piping, but the package itself would have the pumping, the controls, the drives, the valves, all in an enclosure, and then you'd come in, you'd drop that into a traditionally assembled installation. That enclosure itself gets wrung out, pressure tested, and control tested before it gets to the site, so it really minimizes your installation and your commissioning time when you have this installed as a part of your project. To a bigger scale, from an infrastructure perspective, this is a chiller plant that was modular construction for a project we did in New Jersey. We had a client who had a very large building, but he had very little space outside the building to build his infrastructure. They wanted to have the inside of the building. They wanted it to generate as much revenue as possible by putting in as much raised floor as possible. So we worked with them and looked at the zoning requirements and built and worked with a manufacturer and a packager to assemble a very close-coupled, multi-module, water-cooled chilled water plant. What you're looking at here is 2 out of 3 phases of an ultimate size. I think it's 5,400-ton chiller plant. This only extended out, I think it was 50 feet out of the building, which is right at the edge of the setback requirements for the city. So we wound up getting quite a bit of tonnage and quite a bit of cooling capacity built outside the facility, and it made it very simple for installation. Very simple. Nothing is completely simple in this industry, but certainly the fact that they had the chillers run, tested, and the piping tested, and it limited the installation on site to just coupling piping and electrical and controls to the existing building infrastructure systems. It made its case for modularity, as far as we're concerned, for large-scale infrastructure systems. And obviously, it's moved forward into the IT industry, where you've got multiple manufacturers. And I've just picked 3 random images to show you, but you can obviously go to the web and you can find, just type in modular data center, you're going to find dozens of manufacturers that are making prepackaged IT kits now inside of modular components, whether it be an ISO container, whether it be a 12 by 50 size that would sit on the back of a flatbed truck on standard U.S. highways. And these are tight configurations where you'd have computing cabinet, cooling, and power distribution inside that module. That module can tie into an existing building's infrastructure system quite quickly. And it's an easy way to get rapidly deployable IT kit to your site. These can come populated with IT, and they can come empty.